All right, so Unit 9, Day 4 notes. These are our last notes. This section will be split up into two parts. This is Unit 9, Day 4 notes, Part 1. There will be another part. We are going to go over 7 pages this time, and then we'll do 7 pages next time. Okay, so this is Unit 9, Day 4, Part 1. Notes. These are your objectives for both parts. And let's start here. It says, and hopefully you have this printed out so you can kind of see it a little better. It's kind of blurry, but I'll read it to you. A ball is thrown from a height of 32 meters, okay, with an initial downward velocity of 2 meters per second. The ball's height in meters after t seconds is given by the following, okay? How long after the ball is thrown does it hit the ground? And basically they want the height in this situation. When it hits the ground, the height is going to be 0, okay? So before we can do anything with that, we do need to kind of change this around, but our height is going to be equal to 0. So we're going to have 0 equals, and then this situation, what's going to happen here is that I need the t squared to be first, okay? I'm going to put it up here so I can have some room. I need that t squared to be first, so I'm going to move this entire, remember, if it is in the before it, it belongs to it. So I have to move it with it. So negative 5t squared. So that minus belongs to the 5, so it has to be moved with it when we move it. And then I'll have negative 2t, and then 32 is positive, so positive 32, okay? And of course, it's going to be equal to 0 because it says when it hits the ground, that means the height is 0. So this is my equation that I'm looking at. Now, before I can even start to solve it, this squared value cannot be negative. So what I'm going to do is multiply everything by -1. And you only do that when the squared value is negative. Now, these can be negative, but if the squared value is negative, I'm going to do this. So this now becomes 0 times -1 is just 0. Okay, so it doesn't change anything over here, but this now becomes positive 5t squared, and that's what I want. This becomes plus 2t, and this becomes minus 32. So basically everything just changed its sign. This is positive, and that's negative now. So now we can look at these, and we are going to use the quadratic formula to solve this problem, okay? Because we are actually looking for t. So instead of putting x equals blah, 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 it actually will be t equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, quadratic formula. And then for the quadratic formula, we need to know what a is, what b is, and of course what c is, so we can solve the problem. So our a value is our squared value. So the coefficient is 5. So 5 is a, b is 2, c is negative 32. Okay, good. So now let's substitute. So in this case, t equals negative b, which is negative 2, plus or minus the square root. B squared is 2 squared, minus 4 times 5 times negative 32, which is c. And then 2 times 5 is that there. 2 times a, which is 2 times 5. So now what I would do to make this a lot easier for you is just negative 2 plus or minus, we're going to get a number, solid number there, over, go ahead and multiply 2 times 5, and that's going to be 10, okay? So I'm going to grab my calculator and let it do some work for me, okay? So of course, I'm just going to put all of this, I'm not going to put the square root, I'm just going to put the numbers under into my calculator. So 2 squared, turn it on first, 2 squared, okay, minus 4 times 5 times negative 32. Okay, so I put all of that just in my calculator, push enter, and then under here, this became 644. Okay, I do not put the square root in my calculator where I'm doing this. I'm just getting all this here to be one number. Okay, so now what you're going to do is split this up. This now becomes negative 2 plus the square root of 644 over 10, and negative 2 minus the square root of 644 over 10. we're going to get two answers. We may have two answers. We may have one answer. It just depends. You know, with a squared value, you have a potential to have two answers. Okay. So in this case, let's see. Let's put that in our calculator. -2 plus, now we're putting that square root in, the square root of 644. Okay. Let's get that whole answer. Do not do the divided by 10 until after you get an answer here. Got an answer. Now we're dividing that by 10. Okay. So your answer here, and they want you to round to the nearest hundredth, okay, is 2.3. And then will this round or not? Looks like it will, because 7 makes that 4. So this becomes 2.34. If you have a problem rounding, you're going to have a problem in this section, okay, because you're doing a lot of rounding. All right, so now let's get the next part. -2 minus the square root of 644. Get that whole answer, and then divide that by 10. Oops, sorry. All right, so we get -2, and again, we're rounding to the nearest hundred, 0.7. Now, 3 is here, but this 7 makes that 4, okay? So -2.74 is our answer there. Now, anytime in these problems that you're seeing here, anytime you get this negative number, we cannot use it, okay? We can only use the positive number when you're talking about height, or in this case, we are looking for when the ball is thrown on the ground, and T represents the seconds, okay? That's the time, seconds. So we're only looking for the answer as a positive number. So when you get a negative, get rid of it. This is your answer, 2.34, okay, when I rounded it. Perfect. All right, so let's look at page 2. Okay. All right, so a model rocket is, hold on, kind of move this. All right, so a model rocket is launched with an initial upward velocity of 39 meters per second. The rocket's height in meters after t seconds is given by the following. So we have our equation. Find all the values of t, which the rocket's height is 22 meters. So h, in this case, h equals 22. Okay, we want to find all, and it does say find all. So there might be more than one. Okay, might be more than one. But let's see. H equals 39t minus 5t squared. We're going to replace h in this case with 22 equals 39t minus 5t squared. Okay. So when you have something like this, we want to get it so that it's equal to 0, and we would like that t squared value to be positive. So in this case, when we have this, let's add 5t squared and subtract 39t. Okay, let's do the opposite and add 5t squared. And of course, I want that 5t squared to be first. So I'm going to say positive 5t squared minus 39t plus 22 equals 0. Okay, so I did, and now I have a positive 5t squared. Okay, and I have everything equal to 0, which is what I need to use to use the quadratic formula, because I'm going to have to use the quadratic formula just like I did last time. But I got the t squared value to be positive, which is what you need. Okay, there's other ways to do this, but this is the best way for me. All right, so now I'm going to, A is 5, B is negative 39, and C in this case is 22. Of course, I'm using that quadratic formula to find t, okay, because they want to know when it equals, the height equals 22, what is t, okay? So negative b plus or minus square root b squared minus 4ac all over 2a. That's that quadratic formula. Negative 39 plus or minus the square root of negative 39 squared minus 4 times a is 5 times c, which is 22. Sorry about that. It's right there at the corner. And then over 2 times 5, which is 2 times A. Okay. So now, of course, negative and negative for 39 becomes positive 39. Plus or minus, I'm going to get a single number there, and it's over 2 times 5, which is 10. Okay, let's do that in our calculator, get that single number. It's going to be for negative 39 squared minus 4 times 5 times 22. Okay, and we'll get an answer for that. So we get 1081. Okay, 1081 for that situation. So now we can split it up and it becomes 39 plus 1081 over 10, and then 39 minus 1081 over 10. Okay. Let's see if they become positive, because that's what's important. So on our calculator, we're going to put this whole thing, get an answer, and then divide that by 10. So it'll be 39 plus the square root of 1081, and then we're going to divide that by 10. So this now becomes 7.1, and this 7 makes that a 9. So 7.19, okay? And then here, we're rounding, let's do it again. 39 minus the square root of 1081, okay? Get an answer. And then divide that by 10. And we get 0.61. This 2 makes it stay a 1. So this becomes 0.61. Okay, both of these numbers are positive. So both of these are our answers. Okay, so it says if there's more than one answer, use the OR button. So your answer is 7.19 or 0.61. Okay, 0.61. All right, so these are both your answers because they both came out to be positive. And like the last one, if one was negative, we have to get rid of it. Okay, let's do this one. A ball is thrown at a height of 156 feet with an initial downward velocity of 8 feet per second. The ball's height after r seconds is given by the following. So this is the equation. Okay, how long after the ball is thrown does it hit the ground? So if it hits the ground, the h or height is 0. Okay, so in this case, when it hits the ground, h is 0. We're going to replace this with 0. So we will have 0 equals. Now, of course, we've been doing this for a couple of problems now. We have to make this so that it's kind of the squared values first. Let's move that. That's negative 16 t squared. Okay, and then negative 8t. And then this is positive 156. Of course, this negative t squared, we can't have that that squared value negative. So we're going to multiply everything by -1. Same thing with this 0. 0 times -1 is just 0. Okay, this now becomes positive 16t squared. Okay, plus 8t, and then minus 156. All right, so that is what's happening there. And then we're going to go ahead and use the quadratic formula like we've been using to solve this problem. So now let's find A, B, and C. Our A is 16, B is 8, and C is negative 156. Okay, we're using our quadratic formula. We've been doing this. It's the third time we've done this. Our quadratic formula for T is going to be negative B plus or minus the square root B squared minus 4AC all over 2A. Okay, let's go ahead and get our substitution in. Negative B becomes negative 8 plus or minus the square root of 8 squared minus 4 times 16 and then times negative 156, and then 2 times 16, okay, because our A is 16. So now for this T, let's go ahead and get this to be a single number, And then 2 times 16 is 32. Okay. But let's go ahead and put that in our calculator, get a single number there. This becomes 8 squared minus 4 times 16. Oh, my buttons are sticky. Times negative 156. Okay. Go ahead and push enter. I get, it looks like 10,048. Okay. So 10,048 is my answer there. And remember, this takes time. You might mess this up if you're not practicing these things. So now that I have this, now is when I split them up. Negative 8. And remember, this always stays the same. This is what changes, this plus or minus. First, you have a plus here, 10,048 over 32, and then negative 8 minus the square root of 10,048 over 32. Okay, so you may or may not have two answers here. We'll see. Okay, so in this case, let's do the first one first. Negative 8 plus the square root of 10,048. Get an answer there and divide that by 32. So our answer is 2 point, it looks like 8, and this 8 right here stays 8 because that's 2. So 2.88. Okay. And now let's do the bottom, negative 8 minus the square root of 10,048. Get that answer and then divide that by 32. It looks like it's going to be negative. Yes. Negative 3.38, which doesn't really matter. If it's negative, we cannot use it. We can only use the positive. So your answer there is just positive 2.88. Looks like for time is we're using seconds. I want to see. T. Where does it show? It says the ball thrown from T is seconds. Yes. So this is 2.88 seconds is your answer. This one we had to throw out because it became negative. Okay. Perfect. All right. So now let's go to the next page, page 3. Page 3, same situation, but let's see what it's asking us because sometimes it asks you something different and I don't want you to get confused. A ball is thrown, initial height of 1 meter. The ball's height age after t seconds is given. This is the following. Find the value for t in which the ball's height is 2 meters. So basically h is going to be equal to 2 in this case. Okay, so now we have this situation. H is 2 equals 1 plus 5t minus 5t squared. And we can kind of change that so that the t squared is first. So let's move that around so that the t squared first because we know we're going to have to do that anyway. Negative 5t squared. I'm just kind of rearranging it. And then this is positive 5t. And that's positive 1. Okay. So this happens first, but we need it so that it's equal to 0. So I'm going to subtract that 2. Okay. So now it equals 0 equals negative 5t squared plus 5t minus 1 because 1 minus 2 is negative 1. Okay, so minus 1. And now, of course, I can multiply everything by negative 1 because that first number is negative. So this becomes 0 equals positive 5t squared minus 5t plus 1. Now, it may you may feel like, oh, I can just flip those around. It doesn't matter. Please take your time and do all of the steps so that you're not mistaking one. If you miss one sign on here, everything is wrong. Okay, take your time. All right, so we got that. Of course, we know A is 5, B is negative 5, and C is positive 1. Okay, let's do our T equals our quadratic formula, negative B plus or minus square root B squared minus 4AC all over 2A. Okay. So for this negative, of course, we're putting in the problem for T. T equals negative, and then B is negative 5. So negative 5 plus or minus. This is negative 5 squared minus 4 times A is 5, C is 1, all over 2A, and it's 2 times 5. Okay. So once I put that in, negative, negative becomes positive 5, plus or minus. We're going to get an answer in there. And then, of course, 2 times 5 is 10. So let's just go ahead and get that answer. This becomes negative 5 squared minus 4 times 5 times 1. Go ahead and push enter. The answer in here is 5. Okay, so that's a small answer. That's good. All right, so now we're going to split it up. Same thing we've been doing. 5 plus the square root of 5 over 10, and then 5 minus the square root of 5 over 10. Okay. First one is 5 plus the square root of 5. Of course, we're going to get that whole, oops, I didn't put anything in there. 5 plus the square root of 5 and get that whole answer, and then divide that by 10. Okay, I got 0.72. And of course, that 3 makes that 2 stay the same. If it was 5 or higher, they would make it go to 3. But this is 0.72, 0.72 is your answer there. Same thing here, 5 minus the square root of 5, it's your entire answer, and then divide that by 10. 5 minus the square root of 5, and then divide by 10. My goodness, I cannot believe I did that. All right, one more time. 5 minus the square root of 5. Get an answer, and then divide by 10. So by now, you should be really good at this. All right, so your answer is it looks like this 6 is, you're looking at the third number, which is 6, it makes that 8. Okay, so 0.28, and you do need to know how to round here. So you are going to use both of these answers. Both of these are your answers, 0.72 and 0.28. Both of them are positive. And of course, here it says round your answers. It has a little answer, find all the values. Most of the time, they'll try to give you a hint by that. But sometimes it may just be one. But in this case, it is both of these sides because they're both positive. Okay, those are both your answers. All right, so next problem. So graph the parabola to graph, and then to graph the parabola, plot the vertex and 4 additional points on 2 on each side of the vertex. And this is important. I'm going to add a little piece here by giving the axis of symmetry is also important. It's something that may come up later, but the axis of symmetry is important because you're going to basically 2 points on the left side of the axis of symmetry and 2 points on the right side of the axis of symmetry. So first and foremost, let's get the vertex. Okay, the vertex, your x value is always going to be within here. If it has a parentheses, of course, you're going to know it's the opposite of this number here. If it's a negative, your vertex x is going to be positive. If it's positive, it'll be negative. The number on the outside stays exactly what it is. Okay, that's your y value. So your x value here, instead of -5, is actually +5. Okay, and then your y value here, this is +2, so it's going to just be +2. So your vertex is 5, 2. And that's an important point because that's where you're going to graph first. I'm going to go to the right 1, 2, 3, 4, 5, and then up 2. This is my vertex. Okay. As you see, this is a positive number, no negative out here. So this is going to move upwards. You should kind of know that. If it was negative out here, it would go downward. But in this case, it goes upwards. But we need to know 2 points. Now, your axis of symmetry, and they may ask you for this. Okay, I can't spell. Come on. Yeah. All right, symmetry. Okay, that might be right. All right, so your axis of symmetry for that particular one, whatever the x is here, your axis of symmetry is going to be x equals whatever this x value is, 5. So here is your axis of symmetry at your point here is 5. This is always going to be your axis of symmetry, straight down the vertex. Okay, it's going to be a vertical line through your vertex. That is your axis of symmetry. And for this, your axis of symmetry, you're going to pick 2 points over here and then 2 points over here. And then that'll be the 4 points you need, 2 additional on the sides of the vertex. So you're going to pick 2 here, 2 here. So I'm going to make them my values for x and y course, my 2 over here from my axis of symmetry, if this point is 5, I'm going to pick 4 and 3, okay? And then on this side, I'm going to pick 6 and 7. Okay, it really doesn't matter. You could pick some other points if you want, but I'll just do that to make it easier, make my life easier. Since this is 5, I'm just going to do 4, 3, and then the bigger points, I'll just put 6, 7, 2 on that side. Okay, and then I'm going to find those values for y. Okay, by replacing replacing x with all of these values. So let's do that. This now becomes y equals, I'm replacing first 4 with x, 4 minus 5 squared plus 2, okay? And I'm going to get my answer there. Of course, 4 minus 5 is -1. And -1 squared is just +1. 1 plus 2 is 3, okay? So -1 squared became +1 plus 2 is 3. So this is y equals 3 minus 5 squared plus 2, okay? 3 minus 5 becomes -2. -2 squared is 4. 4 plus 2 is 6. Okay, and you don't have to do it this way. You can just put it in your calculator if you want, but I'm going to do it this way in my head. This now I'm using 6. 6 minus 5 squared plus 1. This becomes what? 1 squared is 1 plus 2, sorry, is 3. And then for this one, 7 minus 5 squared plus 2. Okay, 7 minus 5 is 2. 2 squared is 4. 4 plus 2 is 6. So I have all of my points. This becomes 4. When I put 4 in, I got 3. When I put 3 in, I got 6. When I put 6 in, I got 3. And when I put 7 in, I got 6. Okay, so these are points on your graph. That's how you find your points on your graph. So 4, 3 is to the right 4, up 1, 2, 3. Okay, 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And then 6, 3, 6, and then 1, 2, 3. And then, of course, 7, 1, 2, 3, 4, 5, 6. So this is your graph, and those are the points. Okay, here you go. Perfect. All right, so next page, kind of the same thing. You're just continuing on with this thing. I'll go ahead and skip down to this one. Okay, vertex, let's find that first. And then, of course, once we find the vertex, we will find the axis of symmetry. Okay, that's A of X, the A of S, axis of symmetry. Vertex, of course, if this is plus, it will be minus, but it negative. But in this case, it's negative. So your vertex X is +5. Okay, and then this -1 stays the same for your Y value. So your X value is the opposite of what you see here. Okay, so if we were up here, and this right here is X plus 3, your vertex here would be -3, and then whatever's on the outside stays the same, +2. So this vertex is -3, +2. And the problem that we're working on now, this is X minus 5, and then of course that becomes +5, and this -1 stays the same. Axis of symmetry is going to be X equals whatever this X is equal to, X equals 5. Okay, so what does that look like? 5, -1. So 1, 2, 3, 4, 5, and then -1 is here. Okay, so your axis of symmetry goes straight down the middle, a vertical line down the middle of that vertex every single time. That's your axis of symmetry. So you need 2 points from this side, 2 points from that side. Okay, so I need, my axis is 5, I'm 4 and 3, same thing. 4 and 3, and this is 6 and 7. Okay, and I'm going to use this equation. I'm going to replace X with 4, X with 3, X with 6, X with 7, get all my answers. So this is Y equals 4 instead of X, -5 squared minus 1. Okay, So of course, 4 minus 5 is -1. -1 squared is +1 minus 1 is 0. Okay. So I know that becomes 4, 0. For 3, so all those are on points once I get them. So I'm going to replace x with 3 minus 5 squared minus 1. This becomes -2. -2 squared is +4 minus 1 is 3. Okay, 3, 3. And then 6 minus 5 squared minus 1. This becomes +1. 1 squared is 1, minus 1 is 0. And then this one is 7 minus 5 squared minus 1. And that becomes what? 2. 2 squared is 4. 4 minus 1 is 3. Okay, so we do have 0, 3 there. So 4, 0 is here. Okay, plotting a point is super duper important. Gotta know how to plot your points. 3, 1, 2, 3 is here. 6, 0, and 7, 1, 2, 3 is here. So this is your graph for that equation. Okay, using your vertex, axis of symmetry, and these are the points. Got it? Good. All right, let's look at page 5. Page 5 is here. Graph the quadratic function with a vertex 0, -2. Find the range, the graph of the quadratic function is shown basically, and then find the range and domain. For this situation, your domain is for a parabola, which these are called parabolas, your domain is always all real numbers, which basically looks like this: -infinity to +infinity. Okay, and infinities, when you have an infinity, always has a parentheses with it. So your domain is always this, all real numbers. That's what this represents, all real numbers, -infinity to +infinity, because it goes side to side forever. Domain, you're looking here to here. And here to here, what that has arrows, is going to go side to side forever. So that is your domain. For your range though, okay, and this is extremely abstract, so it's not easy. You're looking -infinity to +infinity. You're looking up and down. What's going up and down with the graph? First of all, you'll always start the negative first, okay? And in this case, as you see, it goes down forever with those points. Those arrows are going down forever. So it doesn't always happen like this with the range, but in this case it is. It goes down forever, so you know you're going to have a -infinity. You always have a parentheses with an infinity, okay? So going up, if I start down, which I always start for range, you'll always start down and move up. Here, you'll always start left and move right, okay? So in this case, we started down like we always will. It basically goes down forever, and then it's for the moving up part, do you see that it stops here at -2 once I move up from -infinity? I'm moving up, it stops here at -2, so it doesn't go up anymore. At -2 is the end. So -2, and you put a bracket, okay, when it's a solid line. If it was like an open circle, you'd put a parentheses, but they probably will not have that, but you never know. In this case, you put a bracket with the number where it stops when you're moving up. Let's try the next one, okay? What did I say? Domain and range. Domain is always for parabola, which this is. These are called parabolas. Domain, looking -infinity to +infinity, is always all real numbers, which looks like this, okay? All real numbers. But your range, if you're looking -infinity to +infinity here, so I'm looking here and I never take myself left or right in this. I'm only moving up and down and seeing where my graph is. I'm staying actually on this line here. So if I'm staying on this line, where did my graph start? It started right here. I'm not going to go over to where it is. I'm going to say this is where it started. It didn't go down forever in this situation. It started right here, and this point right here is 0. So for your range, 0 is where it starts. And then, of course, you see those arrows, it goes up to +infinity. Infinity always has a parentheses with it, okay? And this is called interval notation. Okay, interval notation. And that is what it's going to look like. So in 0 has a bracket. And of course, with your range, you're never going away. You're never going away from this line. So I'm not going to go over to 4. I stay right here. So this is where my graph starts at 0, and then it goes up forever. Okay? We don't care where it's going side to side with range. All right, so page 6. These are some important points for this particular section so that we can answer these questions. These are important points you need to kind of pay attention to. Okay, before I'm going to draw a little this little graph right here is I'm going to put something in all of these to tell you, and you should definitely write these down. This is super duper important. But first, before I do that, this is like ax squared. This is the equation of a parabola, basically, because you know you have the x squared, so it's going to be like one of these. Okay. Now, what's important to note is if the absolute value of a, so we don't care whether we're always going to be a positive number for a when we're looking for narrower or wider. Okay. The absolute value of a, to find whether it's wide or narrow, what you're going to do is the absolute value of a is how you find if something is wide or narrow. Okay, you take the absolute value of these numbers. Okay, so what do I mean? For a large number, the absolute value of large number is going to be narrow, and you'll see what I mean in a minute. So your graph is going to be very narrow. Okay, the larger the number gets, the more narrow the absolute value of that number. And then the smaller the number is, it's wider. Okay, so narrow is a large number, smaller something is wide. And of course, you should know negative goes downward, positive goes upward. Okay, so I'm sorry, down, and then of course up. All right, so these are like the important notes on this section. And we'll talk about narrow and wide in just a minute, but I kind of wanted to point this out to you before we started. So here, if a parabola, for each parabola state, if it opens up or down, of course that represents where it's negative and positive. Here, since it's negative, it goes down, because it's negative, positive, up, positive, up. So that's the kind of easy part. Okay, positive or negative represent, so these are both negative, so it's down, positive, so it looks upward, it goes upward. Okay, now choose the parabola with the widest graph. Now we have to look at a, or the number in front, as the absolute value of a. So we need to know the absolute value of this, absolute value of this, absolute value of this, absolute value of this. All of that means is that this is a positive 3, that's positive 2, that's 1/3, and that's 1/2. Okay, now we're looking at these numbers to determine wide or narrow. Choose the parabola with the widest graph. We said the wide one has the smallest number. Okay, wide one has the smallest number. We know 3 and 2 are whole numbers, but these fractions are going to be smaller than 3 and 2. Okay, so we need to figure out between 1/2 and 1/3 which one is smaller. And you can tell by, if you can tell between two fractions, okay, which one is smaller. All you have to do is take this number and multiply by that number, that's 3. Take this number and multiply by that number, that's 2. The smaller number, okay, would be on the smaller fraction. So in this case, 2 is smaller than 3. So this fraction is smaller. 1/3 is smaller than 1/2. So 1/3 would be our parabola with the widest graph. So this one would be the widest. Okay. And then choose the parabola with the narrowest graph. And we said the narrow one would be the biggest number. Our biggest number when we take the absolute value is 3. So this one would be our narrowest. Okay, most narrow. would be this one here. All right. So following our rules are important, and going back to these rules are important. All right. So let's look here. Look at the graphs, and then we're going to basically answer some of these questions. For each coefficient, choose whether it's positive or negative. Super duper, that one's pretty simple. Positive here, negative, negative, positive. Okay, opens up, opens down, down, opens up. So you could tell which one is positive, negative. Choose the coefficient closest to zero. So basically for this one, we are looking for the smallest. It's closer to zero, it's closer to the smallest. We're looking for the smallest coefficient. And remember, we're taking the absolute value, so we only worried about the one closest to zero, so the smallest. And we already set up here, if you remember, the smallest one has to be the widest one, okay? So we don't really care whether it's moving up or down. We just want to know which one is the widest. And in this case, it looks like D. D looks like the wider one to me. Okay, D is the widest. So here it says choose the coefficient with the greatest value. And of course, with the greatest value, it does have to be positive. Positive and negative really matter when you're talking about the biggest something. Okay, the greatest value is going to be positive, so it's going to be either this one or this one. And as we looked here, if it has a large value, then it's more narrow. Okay, so if we're looking at this one and this one looks to be more narrow. So our A, we're looking for positive and more narrow. Okay. And as you see, this little when we wrote this is super, I keep coming back to this because this helps me with these to answer these problems. And you may need that when you're answering your problems yourself. Okay, so write this down and kind of study this. All right, so our last page on Unit 9, Day 4, Part 1 is page 7. And here it's the same exact thing. We will go back to that. If you remember, we said for large, it's narrow. Okay, so our graph is kind of narrow. For small number, or of course, absolute value, it's wide. Smaller numbers make it wider. Negative goes down. And positive looks up. So this is an important note, some important information that I need. And of course, with the narrow and wide, it's the absolute value of that first number, okay? So it doesn't matter whether it's positive or negative. It just that to determine narrow and wide. But the up and down does matter. So here, choose whether it's positive or negative. Of course, these two, this one's negative, negative, positive because it's upwards, and positive because it's upwards, downwards, downwards, upwards, upwards, okay? Choose the coefficient closest to zero. Closest to zero means that it's the smallest, because closest to zero means that it's the smallest, it's the widest, and it really doesn't matter when we're talking about narrow and wide, whether it's a positive or negative. Okay, so this one, it says it's the smallest, it's the widest. So this looks to be the widest for C. Okay, choose the coefficient with the least, and least does really matter for positives and negatives. Okay, so the least value is going to be a negative number, so we know it's going to be either this or this one. Okay, and it has to have the least. So if it's the least, it's the bigger. Okay, it's the bigger, so it's the one that's the most narrow. And it's a negative. So we know it's moving down and it's the more narrow. Okay. So if it has the least, that means it has to be a bigger negative. Okay. So it has to be more narrow. And it looks like to me it's going to be that one. Okay. So that is how we kind of solve that problem. All right. So finally, on this page, we're just going to do a couple of translating problems. It says the graph of y equals x squared. This is the graph of y equals x squared. I kind of drew it in because it wasn't there. Translate to get the graph of x squared plus 3. Now, if this does not have a parentheses, so for this is A, I'll make this one A, and this one, of course, is B, okay? For if it does not have a parentheses in there, plus 3 means you just moved, you took this graph and moved every point up 3, okay? So for this one, I would move up 1, 2, let me draw this, it looks like in another like color, so you won't be confused. So for this one, it would be up 3, so this will be my point here. Okay. Oh, you can't even see it. You can't even see the different colors. So it really didn't matter. Okay. I moved up 3 in that situation. And then here, I would go up 3. 1, 2, 3 here. Okay. Here, up 3, 1, 2, 3. So every point, 1, 2, 3, I just moved basically up 3. And that would be like my new kind of graph. Okay. And on Alex, they're just going to ask you, you just have to make sure you understand that you're moving up when you have this here. Okay. So all I did was move up 3. Now in this, when it does have the parentheses with it, here you have to move the opposite. So in the parentheses, you have to move left 3. Okay. This one is left, 5, I'm sorry, left 5. Okay. If this was a minus in here, I'd move right, whatever. So left and right here, positive, I mean, when it's on the outside with no parentheses, that's when I'm moving up and down. In the parentheses, you move left and right. In this case, because you have to do the opposite, it's -5, you have to move left 5. So here I would move 1, 2, 3, 4, 5. Okay, I take this one and move 1, 2, 3, 4, 5. This 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I'm just moving it right along the same line. 1, 2, 3, 4, and then 5. So this will be my new line or equation. Sorry. Okay, that's supposed to be on there. All right. So this is just basically wanting you to translate, and that is Unit 9, Day 4, Part 1. Stay tuned for Part 2, and then you'll be done. Okay.